Hello everyone, welcome to another repair video. Today we're going to be taking a look at this Nintendo Switch which has been sent in. And this particular console has been sent in because it has charging issues. So the first thing I want to do is try and establish roughly what's going on with it based on what kind of current is being drawn from the USB ammeter. So I'm going to plug it into a USB source and we'll figure out roughly what's going on with it, hopefully. So, a little bit of a stretch here, but you should be able to see that. There we go. So, this is plugged into my computer right now. So, let's have a look at roughly what's happening. And USB detect picks up that it's plugged in. And we're getting 0.09 amps current draw. And then 0.00. Okay, so we've got an initial burst of 0.09, so 90 milliamps, and then nothing. So that's telling me that we've got an issue with M92T36. 0.07 to 0.10 is generally an issue with M92T36 when we are connected to a 5-volt charger. This is a 5-volt charger, but it's got a little bit of voltage drop because of the USB cable, but that's absolutely fine. So let's take it apart, we'll see what's going on with it and we'll see if we can get this thing working again, shall we? While I've got your attention, if you're new to the channel and you like this type of content, don't forget to hit that subscribe button down below and turn on the bell notifications so that you're notified every time that I upload. Now that the board's out, the first thing that I'm going to want to do is just inspect the USB-C port, make sure that we've got no damage on that, and then we can do some tests using the multimeter and try and figure out roughly what's going on with the motherboard. Because usually when we've got charging issues on the Nintendo Switch, it's usually related to M92T36, which is this IC just here. So this chip is usually what's faulty, or the P13 USB on the back, and that's usually caused by damage to the charger port. So we'll inspect that under the microscope and then we'll do some tests on the multimeter and try and figure out what's actually going on. We definitely have some damaged pins inside there. So we can clearly see that the charging port is going to need replacing. And if we take a look on the edge, we've got a few pins here which are damaged. So we've got this one here, and we've got a couple here as well. So what we're going to do is just take off the charging port. That's going to need replacing, but we can't do any testing on the board until that's done. And the reason for that is because if there's anything shorted out in there, or there's anything damaged, it can give us incorrect readings. So we'll take off the charging port first, and then we'll work on doing some sort of testing afterwards. So what I'm going to do is I'm just going to use the hot air gun at 480 degrees Celsius and get this port removed. So what I'm going to do is just get this port removed by using hot air, and then we'll take it from there. So the way that I'm going to remove it, I'm not going to use any kind of low melt solder or anything like that. I'm just going to use hot air on its own. And I'm going to heat up the general area until I start to see the ground legs go shiny, and then even after I see the ground legs go shiny, I'm going to still leave it there to heat up some more. The reason for that is because I don't want to lift this port too early and cause damage to the pads underneath. So every so often I'm just coming in with the tweezers and just giving it a tap, see how we are, just see how it's doing. And there we go. So you'll notice there that I didn't try and rush that. I just took my time and let it do its own thing. And the reason for that is because those traces are very, very fragile, and removing that port without paying attention is going to cause problems. And the traces themselves are very difficult to repair. They're around about 0.3 millimeters in length, and that's just not easy at all. So very, very carefully we get that port removed, and now we know that we're not going to have a short inside the port. So with that out of the way, the next thing I want to do is hook up the multimeter and try and figure out exactly what's going on with the power management ICs. Like I said, one of the causes of no power could be down to the M92T36 chip, which is this chip here. That's the USB-C power management and power delivery chip for the Nintendo Switch. And this is the most common cause of no power. You can buy these relatively cheaply on eBay and AliExpress. They're not too expensive. Just go onto one of the websites and type in M92T36 and you will find these chips. If you buy them in packs of 10, you can get them for about £2 each, or around about $3 US. So not too expensive there at all. Okay, so as you can see, I've got the multimeter on the screen there. And like I said, I'm going to do some tests in continuity mode and just figure out what's going on. So multimeter is in beep mode, and I'm going to pop one probe on ground. So in this case I'm going to use the ground shield next to it, and I'm going to test the input side of the capacitors around here and see where we're at. So no short, no short, and we have a typical short on pin number 3. So that's kind of normal, or rather on capacitor number 3, that's kind of expected. And also a short there as well. Let's test this cap here. We just want to see if we have a short on P13, and it doesn't appear so. So this capacitor here is related directly to P13 USB on the back, and that typically goes when we have power issues. And when that goes, we usually have a short on this big cap here. So let's check that cap anyway, just in case. So once again, we're going to pop one probe on ground. And we don't appear to have a short on P13, so this should just be a USB-C port and M92T36. So that shouldn't be too bad to get repaired. So let's remove M92T36 first and foremost. Just get that chip off. So I'm just going to use 480 degrees Celsius at 50% airflow and just pull the chip off. There we go. And with the chip removed, let's just check and see if that short is gone. So we'll turn the multimeter back on there, and let's pop one probe on ground again. And the short is gone. Good, that's excellent. Okay, so let's get a new chip on, and then we can put a new port on, and we should be good to go. It should be done. I don't see any more reasons why this wouldn't have no power. So we should be good to go there. So I've got a replacement chip there. So I'm just going to get that roughly in place. And what I'm going to do is I'm going to knock my airflow down to 30%. And I'm going to knock it down to 440 degrees Celsius for the installation. And first thing I'm going to do is basically just tack this chip down in place, because I want to add some flux, but I don't want the chip to fly everywhere when I do so. You'll notice I'm not replacing the solder, and that's because it's completely unnecessary in this instance. So I'll just tack the chip down there by putting a bit of hot air onto it. And then once the chip's roughly in place, I'm going to add some flux. I'm going to let the hot air do all the work. So right now, hot air and surface tension are going to be your best friend. And as long as it's roughly in place, you'll notice I shouldn't have to touch this chip. I'm going to increase the airflow to 40%. I'm going to keep the hot air the same. And I shouldn't have to touch this chip. It should just put itself into place. There we go, and that's perfectly lined up. Just going to press down on the chip now. And reflow it once more. Give it a tap, make sure it stays in place, and it does. So that chip should be soldered, and we should be good. So the reason replacing the solder isn't necessary there is because there's nothing wrong with the solder that's on there. Yes, it's lead free, but there's absolutely nothing wrong with it. And why risk knocking components off if there's nothing wrong with the solder that's there? So just clean it up with some isopropyl alcohol and a toothbrush. Just get rid of the excess flux off the board. And then I'm going to use hot air just to dry the rest off. And then we can inspect the chip. So if we zoom in and have a look here, just get that in focus, and you can see that the chip is perfectly lined up. It's a little bit dark, but that chip is perfectly lined up and good to go. We have more than enough solder on each of them pads, and that's perfect. Perfect, perfect, perfect. Okay, so moving along, the next thing I want to do is add some flux to the USB-C area. And the solder on this part we do want to replace because we want to lower the melting temperature for the USB-C port installation. And the reason for that is because there's obviously plastic inside the connector, and we want to put as little heat on that area as we possibly can while we're installing a new port. So we're going to replace the solder that's there with some fresh leaded solder. I'm not going to wick away the old solder. And someone asked me this in the comments the other day, saying basically he can't believe I don't wick away the old solder. There's no need to. So adding leaded solder to lead-free solder will mix up the composition, and it will basically change the way the solder melts. It'll change the temperature, but there's nothing wrong with the solder that was on there. So we don't need to wick away. We don't need to risk putting any kind of excessive pressure on these pads. So we'll just add some leaded solder, and that is it. We don't really want to be wicking away on this board. It's super thin and it's super easy to pull these pads. The one thing we can wick away is the ground holes. So we can wick those away, and I will do that just to make it easier to actually install the new port. But other than that, we don't want to put any excess pressure on the pads. So we'll clean away the ground holes as best that we can. And you'll notice I'm trying to avoid these pads if I can. There we go. Alright, let's clean up the area, and then we'll add some fresh flux, and I'll drop a port onto the motherboard. There we go. Just dry the area off with some hot air there. And then just zooming in on these pads, you can see that we've got a nice even amount of solder on all of them, which is absolutely perfect. That's what we want to see. So what we can do now is just basically use hot air and drop a new port on. But first we want to add some flux to the pads themselves. so to the middle area here. We want to add some flux there just so as the solder flows nicely. And then I'm going to grab a brand new port straight out of the strip. What I'm going to do is I'm going to use my hot air station without the nozzle now, because I want to transfer heat evenly across the entire area. So my hot air is set to 440 degrees Celsius and my airflow is set to 40%. What I'm going to do first is just heat up the area, get some heat into the general area on the board, and then I can start to drop the port into place once I see the ground legs where the pads are start to melt. So what I'm going to do now is just keep the air flowing. And in a minute we should see this port drop down into place. Okay, I'm going to move the hot air away. This is not going to be soldered yet. I am going to need to reflow it. It's not going to be fully soldered yet, but I want to add some more flux now to the back of the port. So plenty of flux there, just get that solder flowing nicely. And then I'm going to increase my airflow now to 60%. I'm going to increase my hot air to 480 degrees for the last quick reflow. And then I'm just going to keep the hot air moving so as not to melt the port. Every few seconds I'll stop. I'm going to press down on the port. Press and hold while I move the air away. And that should be solid. Should be in position. It certainly seems to be, according to what I can see. So let's take a look, let's inspect it. This may need one more reflow. It may need pushing down on that right hand side a little bit. I'm going to say that it most likely does. And yep, so it needs pushing down on this side. So let's do that once more. That should be good. That should be fine. That looks a lot more level now. Perfect. Every pin soldered. Okay, so let's clean up. Let's use some isopropyl alcohol and a toothbrush. just clean up the area, and then I'll flip the board around, solder those back legs back in, make sure that it's secure, and then we should be good for testing. It should be absolutely fine now. One thing I'm going to do is just clean off the old thermal paste here. So I'll use a cotton swab for that and just wipe it down. Because when we reassemble this, we're going to need to replace the thermal paste anyway. So we may as well do that now. Get it nice and clean with the toothbrush. And then dry it off. Perfect. Okay. One final thing I want to do before I put this back together is I just want to check the fuse. So there's a little fuse just here, right in the middle of the board. And I just want to check that fuse for continuity, make sure it hasn't blown the fuse when we had the damage to the port. It shouldn't have done because of the pins that was damaged, but we never know, so we're going to check it anyway. And as you can hear by that beeps, so we've got continuity across that fuse. So the fuse should be fine. We should be good there with that. Let's get it tested. So what I want to do now is I just want to plug in the basics. The basics are going to be the battery, the LCD, the backlight, and the power button, and that is pretty much it. That's pretty much all we want to plug in, and the reason for that is because if it does have any more issues, then we don't really want to be putting it all back together just to have to take it back apart again. But it should be absolutely fine now. Shouldn't be any more reason why this won't work. We do have a little bit of thermal paste there to get rid of. There we go. But there shouldn't be any more reason why this won't work now. So I've connected the fan and the power button. I've also connected the backlight and the LCD and the battery. Let's see what it does this time, shall we? So let's get the USB ammeter back. Let's plug it in. And let's see what we get. So we get 4.68 volts, 0.45 amps. But we don't get anything on the LCD. So it does appear as though we're charging. On both sides of the port as well. But we've got no display. Right, the backlight is on, so we've got no display, so there's something wrong with the LCD connector there. That's quite annoying. I hate it when that happens. Right, let me just inspect this under the microscope and just see if it's damaged to the connector or if it's just not connected correctly before we sit there messing around with it. The connector seems perfectly fine, so it's probably just a connection issue. So let's have a look and see if we can get it reconnected. One thing we do need to do is just disconnect the battery. The backlight is on, which means the console is turning on now, or at least it's charging. There we go. We've got a display. So it was just a connection issue there. Perfect. Right, so one thing I need to do now is I need to leave this to charge for quite some time because the battery is going to be completely dead. So what I'm going to do is I'm going to bring my 15 volt charger down and I'm going to leave this to charge on the official switch charger. And the reason for that is because I want to charge it as fast as I possibly can. So I'll charge this on a 15 volt charger and then once it turns on, I'll be back. Right, okay, and that is turning on. So it's currently on 11%, or 10 or 11%, something like that. But let's just plug it back into here now and we'll see what's going on with the charging. So we can see that it's charging on that side. So let's flip the cable around and let's just check it that side. There we go. and it is. So charging port is installed absolutely fine. One thing we do need to do is just test it on the dock and just make sure it docks. So I'll do that now. And there you go. So that's coming up on the dock. So I don't have any Joy-Cons connected, so I can't test anything else until I put it all back together. But that seems to be working absolutely fine. And there we go. Absolutely awesome. So looks like this job is done. What I'm going to do is just get everything back together, and then I'll give it a proper test, make sure that everything's working properly, and then I can call this job done. Right, so one thing I need to do is just test this Joy-Con rail, because I don't like the way that went in. It didn't feel like it went in properly, so I'm going to check the Joy-Cons now before I do anything else. So I'm going to take my own Joy-Cons here, known good Joy-Cons. That's paired, so it's working fine. Okay, so it's just a little bit stiff, which is absolutely fine. Yeah, that's working. Cool. Let's test this one. So I'll do the rest of the tests now. So let's check the controllers, and let's double check. Well, the fan's spinning. I've just stopped it with my finger, but the fan's spinning, so it should be charging the Joy-Cons. As you can see, the fan is spinning there, which is absolutely fine. So it should be charging the Joy-Cons, but I'm going to double check anyway. And it is. So basically, the reason I checked that is because the fan connection is linked to the Joy-Con power. So the fan power is linked to the Joy-Con power, and usually if we've got no fan spin, then we've got no controller charging either, so it doesn't charge the Joy-Cons, and it also doesn't spin the fan. That's usually related to this MOSFET just up here. So I always check and make sure. Let's test the Wi-Fi. There is a subliminal message in that there. That's the Wi-Fi password there. Bink, bink. There we go. Wi-Fi works. Excellent. Okay, so that's updated the time, or the time and date. So let's check a game card now. Make sure it reads that. This is Crash Insane Trilogy. And right, it's not reading that game. Ah, there we go. Okay, so it's just my game. I mean, this game is my test game. It's been in the workshop for God knows how long. It needs a good clean now. So yeah, everything seems to be working absolutely fine. So this console's pretty much done. All that I've got to do now is put this back together. But for the sake of the video, I will be ending it there. So let's just summarise on this then. So this console was sent in because it had charging issues, and by inspecting the charging port, we was able to determine that the charging port was faulty, and that caused a knock-on effect on the M92T36 power management IC, which is this little chip just here. So by replacing both of those, this console now charges and turns on absolutely fine. Everything else appears to be working, and this customer is going to be happy. But that's going to be it for this video. Thank you very much for watching. If you do have any comments or questions, leave them down in the comment section down below. I will always do my best to get back to you. If you do want to organise your own repair, there'll be contact details in the description where you can get in touch with me and organise a repair. If you like this type of content and you want to see more repair videos, then be sure to hit the subscribe button and turn on the bell notifications so that you're notified every time that I upload. And if you enjoy what I do and you want to support the channel, I do now have channel members, so for as £1.99 per month you can support what I do here. But that's going to be it for this video. Thank you very much for watching, and until next time, see you later. Bye for now.